in 1908 when Minkowski really laid it out in a strict space-time.
And that also led to the work on special relativity, led to the speed limit, the speed of light.
Well, it was a premise. He had two premises. One was that the laws of nature are the same for everybody. So if you're moving at some speed, or if I'm moving at some speed, I can say I'm not moving and saying you're moving at some speed. That's not controversial. That is what we call Galilean relativity. It's from hundreds of years ago. But what Einstein said that was controversial was that everybody measures that the speed of light is the same, irrespective of how we're moving with respect to each other. You'll measure the speed of light to be a number. I'll measure the speed of light to a number. And that's very, very different from what Newton would have said or Galileo or any of the old guys. And it was taking those two things together that caused all of the weirdnesses of special relativity. Now, you could then very easily say, well, that second premise that everybody measures the speed of light to the same is just dumb. And you could test that. So that's where testing relativity comes in. And Einstein's equations, which include those two assumptions, it predicts the behavior of everything perfectly well. Now, we've actually measured, done experiments where we can say that the speed of light is the same for everybody. That's not how that's been in the beginning. It was really that assumption leads to predictions. The predictions are true, so the assumption is true. Now, there is for those people, for your viewers who want to say, well, how do you measure that the speed of light is the same for everyone? The particle physicists do this. And the way you do this is the following. There are some subatomic particles that, when they decay, they emit light. That's their decay product. And so you collide two things together so you know when the particle was created. Then you have surround your collision point by a detector, and you measure how long it takes for light to get to your detector. And by God, it's the speed of light, which it should be. However, sometimes in these collisions, some of these subatomic particles you make are coming out at very high speed. They might be coming out at 95 or 97 or a very large fraction of the speed of light. And then they decay into photons. And so you measure how long it takes for the photon to get to your detector, and it says light travels at the speed of light. Now, if it were that, if Einstein's conjecture was incorrect, you'd have a particle coming out at near the speed of light. It would be decaying into a particle traveling at the speed of light. Then that particle should have traveled at, say, 2 times the speed of light or something like that. So it should have taken half as much time to get to the detector, but it doesn't. So this is a hard, serious measurement that shows that something, we can measure the speed at which light comes out of this stationary created particle, and it's the speed of light. Then we can measure what the speed is of it coming out of something that's moving, and it's still the speed of light. So that is an actual measurement, but that is not something that was possible in Einstein's day, but it is now.
Just to take a small tangent, how weird is it? In the full ranking of weirdness that is physics, how weird is it that there's that speed limit of this speed of light?
Well, I have to tell you, when I first encountered this, it's pretty freaking weird. It's like pegs the weird meter. But as you become more familiar with it, as you become more comfortable with the idea, the thing to remember is the speed of light. It's the speed of light through space-time. Once you embrace that, that makes a whole ton of sense. It all of a sudden makes everything fall much more into place. I think that there is an ultimate speed isn't that shocking. It just simply says that it's a property of space in the same way that there is, space can transmit a certain strength electric field. It can support a certain things. Whatever space is, and we don't know what space is, but whatever it is, it has the capability of transmitting these things at that one speed through space or time. And everything else comes from our insisting that we keep space and time different. That's how I view it. And at least for me, that once I accepted that, it all became very comfortable.